Hello, this is Mr. Stein, and in this video we are going to look at Chapter 6.1, the slope of a line. By the time you're done this lesson, you should be able to relate the slope of a line to a rate of change, quickly tell slopes that are positive, negative, zero, and undefined, determine the slope of a line from a graph, and draw a line of a given slope, and determine the slope of a line between 2 points using a formula. Now let's take a look at the vocabulary and some basics. A rate of change. I'm just going to use an example of one. It's how fast something changes. And a common example of one is kilometers per hour. So for example, a car is traveling 50 kilometers per hour. This is a rate of change. It's the change in the car's position. If I was to graph this on a graph, I'll just draw this out really quickly. I would put my time here, measured in hours, and my distance here, measured in kilometers. So this graph would go up like this. Every 1 hour, it goes 50 kilometers. So the kilometers is our rise. The time is our run. So the slope of a line. The slope of a line is given to us by the variable m. And it's equal to the rise of a graph over the run of a graph. And in this last example, our slope was kilometers per hour. It was a rate of change. So slope indicates a rate of change. It can also be used to measure angles without using a protractor. It's a very convenient way to measure the slope of a hill, what angle it is. Right, so there's all kinds of rates of change that can be measured with slope. But let's take a look at slope in some basics. We have two lines here. And we're going to do the first line right here. We're going to look at the slope of this line. We're figuring out slope. We always mark one point on the line. And then we try to choose a second point where the line crosses the grid. And we work from left to right. Our slope is equal to our rise over our run. So I count up the rise. 1, 2, 3, 4, 5, 6. The rise, it goes plus 6. And the run, plus 3. So in this case, our rise is plus 6 over a run of plus 3. I'm always trying to work from left to right on my points. That's the way I always do it. So it's equal to plus 2. It goes up to every 1 over. Now, you could choose these 2 points and compute the slope. You have plus 2 up and plus 1 over. Gives you the same slope. All right, let's look at the second one. We choose 2 points where it crosses the lines, and we go down, and we go over. Now this one, starting on the left, going to the right, it's going down. 1, 2, 3, 4. Down 4, so our rise is negative 4. And it goes over 1, 2, 3, 4, 5, 6, over plus 6. So our slope is equal to our rise over our run, which is equal to minus 4 over 6, which is equal to minus 2 over 3. And keeping the slopes in fractional form really helps you work with them. So unless otherwise specified, you leave your slopes in fraction form. It asks you for a unit rate, so like kilometers per hour, meters per second. Then you change it to a decimal, so how many meters in 1 second. All right, we have 3 formulas to express slope. First one, slope is equal to the rise over the run. That's easy. Our second one, slope is equal to change in y, and all change in y means is our rise. It's how much the graph goes up and down over the change in x. And all the change in x is our run. It's how far left and right. So it's just another way to tell, to say rise over run. Change in y over change in x. Now, another way to say change in y is to write it as a formula. So change in y is equal to y2 minus y1. That's one of the y values minus the earlier y value. And our run is x2 minus x1. We're going to demonstrate this formula next. Okay, so I have 2 points. I'm going to put 2 points on this graph, and we're going to figure out the slope between them. So point A is equal to 1, 2. We can do 2 pretty easy points. Point B is going to be equal to, let me just choose a nice point here, 4, 8. Okay, so let's take a look. What we're going to do is we're going to use this formula first, and then we're going to look at how that is on the graph. Okay? So, our formula, m is equal to y2 minus y1 all over x2 minus x1. Right? I write my formula first. Now I choose one point to call point number 1. I'm going to call this one point 1 and this one point 2. If letter B is point number 2, then this is going to be x2 and this is going to be y sub 2. If point A is number 1, then this is going to be x1, y2. So my slope is equal to y2, which is 8, minus 2, all over 4 minus 1. Our slope is equal to 6 over 3. Our slope is equal to 2. That's how you work the formula. Now let's relate that formula to the graph. So I'm going to keep that formula on. I'm going to put these points on. Point A is at 1 and 2 right here. Point B, sorry, I'll label that A. Point B is at the point 4 and 8, which is right here. Okay, now let's take a look at the line between them. And now let's do the rise. So it starts at 2. It starts at 2 and goes up to 8. So our rise is plus 6. Now, if you look over here, you can see where those numbers come from. We did 8 take away 2 to get a rise of 6. 8 take away 2 to get a rise of 6. Now let's look at our run. Our run starts right here at plus 1 and goes over to plus 4. So let's look over here. Our run is 4 take away 1, which gives us a run of plus 3, which is right there. There's our run. So there's our rise and there's our run. So there's our run. There's our rise. We just computed it with a formula. So our change in y, if we look here, our change in y was this plus 6. Our change in x was this plus 3. All right, so you should be able to, given 2 points, determine the slope using this formula. All right, let's take a look at the types of slope. Positive slopes. Positive slopes always start low and go up to the right. That's a positive slope. This is a positive slope. This is a positive slope. These are all positive slopes. They're going up to the right. While negative slopes are going down to the right. These are all different negative slopes. You can have steeper negative slopes, shallower negative slopes, but those are all negative slopes. No slope. No slope means it's not going up or down. No slope means no rise. So there's no delta y, or no rise. But what would an undefined slope look like? Well, what if there's no run? An undefined slope is a vertical line. So these are undefined. There's no delta x, or no run. Now, I'm going to do an example with this undefined slope just to show you why it's undefined. Let's take a look at this line right here. So slope is equal to our delta y over our delta x. In this case, our change in y goes up 1, 2, 3, 4, 5, 6. It goes up 6 divided by no delta x. So 6 divided by 0 is equal to, gives you an error on your calculator because it's undefined. So straight up and down lines have undefined slope. Horizontal lines have no slope. Positive lines are going up when you look at them from left to right. Negative slopes are going down when you look at them from left to right. All right, so I hope you can see how the slope of a line is related to a rate of change, like kilometers per hour in a graph. You can quickly tell slopes that are positive, negative, 0, and undefined. You can determine the slope of a line from a graph. That's what we did right here. And you can draw a graph of a given slope. We haven't done any of those yet. We'll do that in the examples. And you can determine the slope of a line between 2 points using a formula. That's right here. All right, I hope this was helpful for you. If you